Hello, in this video, we'll be looking at some exercises from 4.3. Said if the f inverse of this function is this. So in other words, we have this as our function. We want to find inverse. So we can start by writing y is 2 to the power minus x plus 1 minus 3. And then we try to solve x in terms of y. So this will be y plus 3 is 2 minus x plus 1. And then we can take the logarithm of both sides. So you can take log to base 2 of both sides. We will have this. And here, if you take log to base 2 of both sides, this will go. So we will have actually log to base 2 of 2 to power x minus this. But this log 2 of 2 is 1. So we just have log base 2 of y plus 3 is equals to minus x plus 1. And that means that x is going to be 1 minus log to base 2 y plus 3. Now we can interchange between x and y. So y is just 1 minus log to base 2 of x plus 3. And this y is actually the f inverse. So f inverse is 1 minus log to base 2 x plus 3. So this is the inverse function, which is a. Now for question number 2, we're interested in finding the domain, right? So to find the domain, what can we do? So here we see something here that this is what we have. But if we look at this, we already know this, that when we have log to base a of x, there are certain conditions on this. We know that the x, a, which is the base, should be greater than what? Positive, and it cannot be 1, right? But x has to be greater than, has to be greater than 0. So we're going to apply that here. So if you compare this now, the function that we are given, you will see that this is true. So this x minus 1 here, x minus 1 is taking the place of what? So what I'm saying is that this x minus 1 here is taking the place of this a, right? It's like standing like a. So they have to share the same property, right? So they have to share the same property, this one. So what does that mean? It simply means that if you look carefully, it means that this x minus 1 has to be what? Greater than 0, comma. And this is and, so all these are properties must be satisfied. A, not a now, but x minus 1 should not be equals to 1. So these are from just these two properties, right? All right. So another thing we can see is this one. We can say, okay, this position of x is the same thing as this position of this x. So we know that it means that x has to be greater, right? So the x itself has to be greater than 0. That's what it means. All right, so let's pick that marker. And it means that this x, we can put it as x has to be greater than 0. So it means that all these conditions need to be satisfied. But what is this? X greater than 0 means x is greater than 1. Sorry, x minus 1 greater than 0 means x is greater than 1. And also, you can use and because all these conditions need to be satisfied. This means that x is not equals to 2. And x has to be greater than what? Than 0. So actually, this is what we have. we have something like this. X is greater than 1, right? So let's assume you have the point 0 here, and then you have the point 1 here, right? So which one are we going to take? We said X is greater than 0 here, and here X has to be greater than 1. So it means you cannot take this part. So we have to go, okay, let's look at this one. X greater than 1 simply means this, we can take all the intersection. So this is S greater than 1, all right? So let's take another one here. X greater than 0 is this one. So this is X greater than 0. So let's change this one, X greater than 0. Let's write it in blue. And now we have X is not equals to 2. What is X is not equals to 2? Let's use the black one. So this is X is not equals to 2. So it means that if this is 1, this is 2. So it means we have to open everything at where? At 2. So it means this also has to be open. This also has to be open at 2. So if you look carefully, where is the intersection of all of this? It's just going to be here and what's and here. So it means the domain will just be from where? From 1 to 2, then union 2 to infinity. All right. Okay, so let's look at number 3. For number 3, we want to find this domain of f of x equals to log of what? Absolute value of x minus 4 over root of x minus 3. Now, what can we do in this case? We know this is logarithm, so this cannot be 0. All right, so what we can do is, we know that what's the domain of what absolute value is the whole R. So if it is in the whole R, we can say that the absolute value, for this absolute value, we know the domain is what? Is the whole R. But we know that x cannot be 4, because if x is equals to 4, this absolute value will be 0. So you have 0 over something, so which will be 0, right? And we cannot take the logarithm of 0. So it means for this one, we have to remove 4. So it means we're going to have minus infinity to 4 union 4 to infinity. But in the denominator, we also have this one, right? Since we have this, what we can do is we can use the fact that this, for this domain to be defined, this is the, what do you call it? The even roots. So for the even root, we have x squared minus 3. What is the domain of this one? If you want to find the domain of this, it means that what? You will have x minus 3 to be greater. It cannot be equals to 0 because it's coming from the denominator, right? So this means that x is greater than what? Than 3. So we have to just intersect the two, right? We have to intersect the two. So how do we intersect the two? We just go from here, and this will be 4 somewhere here. So you have minus infinity to 4, and then 4 to infinity. So this is the domain coming from the absolute value. But here we have x has to be greater than 3. So if x has to be greater than 3, then it means we have to move from 3. Also, we have to go this way. So you see, it means you cannot take any number behind. So this will just be the intersection of this one. this. So it's going to be 3 union 4, up to 3 up to 4, then 4 union what? Union infinity. And as you can see here, you can always test, because another way is that what is the goal? You know, we have, let me solve it in a different way that might be okay for others. So we want to find the domain. So the domain, we just want we want this, the whole of this, right? We want the whole of this to be what? To be positive. So we can use the idea of what? The rational, what do you call it? The table. You can use the idea of table. So we can have something like this. What are the zeros of the denominator? We can have 3 is coming from the denominator and 4 is coming from the numerator. And all of them have to be what? Open, right? So here we have x minus 4 in absolute value, and here is x minus 3. So we are doing tests. So if you want to test, you take any number from minus infinity to 3. Absolute value is always defined, so it's not a problem. This is defined, this is defined, this is plus. But you cannot take any number from where? From minus infinity to 3. For example, if you take 2, this root will not be defined. So here is undefined. So let me use this symbol. It means it's undefined. Or let me just put it undefined. Right? So since it's undefined, you cannot talk about what will be the sign here. So here, it means it doesn't make sense. Between minus infinity and 3, this function itself does not make sense. But if you take any number here between 3 and 4, for example, if you take 3.5, root of 3.5 minus 3 will still be what? Positive. So we have positive here. Or you take any number here above 4, let's say 5, here will still be positive. So we have positive. So you can see the only two places where we have greater than 0 from 3 to 4 and from 4 to 4 to infinity. So that is another way of doing it. If you don't want to do this intersection thing. All right. So let me explain this intersection on again. You see here, this is absolute value. So you consider the domain of the numerator and you consider the domain of what? The denominator, right? Yeah. And just find the what? And just find the intersection. Okay. All right. So here in this number 4, we want to find the domain as usual. We'll say the domain. The domain are simply the values of x that are greater than what's greater than, we can say all x in R such that what's x plus 2 over x minus 3, x minus 1 is greater than 0, right? So here we can just go straight and use our table. So what do we do here? We put the zeros. What are the zeros? So x equals to 1, minus 2 is the smallest, followed by 1, then followed by 3. And all of them have to be what's open, right? So minus 2 is coming from where? The numerator, which is this. And 3 and 1, they're coming from the denominators. So here we can have x plus 2. And this is just going to be x minus 3 and x minus 1. So we have to list all the factors to do the sign test, right? So this is x minus 3 and this is x minus 1. So if you put minus, substitute minus 3 here, this is going to be negative, and this will be negative, and this will be negative. So eventually we're going to have negative here. Between minus 2 and 1, we can use 0. This is going to be positive. This will be minus, and this will be minus. So we will have positive. Between 1 and 3, we can use 2. This will still be positive. This will be minus. This will be positive. So this becomes minus. And then you can use 4. Substitute 4. This will be plus, plus, plus. So you have 3 pluses. So eventually we'll have positive. So it means we are going to find minus 2 to 1 open, union, what? Union 3 to infinity. So this is it. So for question number 5, we want to find the interval where this graph of this function lies above the x-axis, right? So what we're going to do is we need to graph it. So we can start with the graph of this is ln, so we can start with the graph of ln x, right? But what is ln x? Ln absolute value of x. We know this is the same thing as log to base e of x if our x is positive, and this is log to base e of minus x if x is less than 0. So this will just be something like this. This will be this one and this one. So this will cross the x-axis at 1, and this will be at minus 1. So here you can see that the horizontal asymptote is, the vertical asymptote is x is equals to 0. So this is the graph of log to base e of the absolute value of x. And now what we can do is that we can reflect it across the what? So let's reflect across the y at the x-axis, right? And now why we're reflecting across the x-axis is because of this minus here. So if we reflect across the x-axis, it will be something like reflecting this across the x-axis, you will just have something like this, and also something like this one. So this is the reflection across the x-axis. And here will still be minus 1 and 1. So this is the graph of minus ln. You can use ln, it's okay, it's still the same. X. Okay, then finally we have towards, let's shift everything 1 unit to the left. So this will be horizontal translation, 1 unit left. So if we move everything 1 unit left, what is going to happen? So here it means this point, you see this point minus 1, you move it 1 unit left, it means it's going to cut at where? It's going to cut at minus 2. So the horizontal asymptote is going to change. I mean, the vertical asymptote is going to change. So we will have something like this. So here now is going to be -2 because we're moving 1 unit left, right? And here used to be 1. So when you move it 1 unit left, means it's going to cross at where? It's going to cross at 0. So this also is going to cross like this. Let's move this a little bit closer. So here is -2, here is 0. Our vertical asymptote is x equals to -1. So this is the vertical asymptote. So the whole of this is the graph of minus ln absolute value of x plus 1. So if we are looking for where it's above the above the x-axis, because above the x-axis means you're looking for y positive, right? So you can see here, all this part is above the x-axis. So all of this is above the x-axis. So you're looking for this portion, and also here. But you need to take the what? We need to take the x interval. So it's going to be from where? Above the x-axis will be from -2, but now up to the vertical asymptotes, but it's going to be -1 open union, then from -1 to 0. Yes. So if you're looking for below the x-axis will be from -infinity to -2, then what's 0 to infinity. But above the x-axis is this portion here. So it's going to be from -2 open up to, it will come close to -1, then from -1 to 0. Right, so the answer here it's A. So let's look at this one. This is 1/10 all to power log 3 plus this. So we're going to have, what we can do is just to simplify. So this is 1/10 log 3 is the power, right? But what is this? If you look at this carefully, let's deal with the first part. This we can write as 3 to power what? -1, right? All to power what? Log of 3. But this log 3 is actually 10 to base what? The base is 10, yes? So with that now, what we can write these as what? I can write this as 10 minus log to base 10 of what? Of 3, which I can write as 10. This -1 can go up. So now you have log to base 10 of what? 3 to power -1. Is that okay? Then this is nothing but 10 log of 10 of 1/3. And as we know from one of the property, this will just become what? This is just 1/3. All right. Okay. Then let's do the second part. The second part is this one here. This one is simply log to base 3/2, 8/27, right? And now we can write it as log 3/2. If you look at this carefully, this we can write as 2/3, everything to power what? Everything to power 3, right? Okay. So what can we do now? This 3, we can bring 3 down. Or another way to do this, you just say, okay, let this be equals to x, right? Or m. You can send it to the m. So change it to exponential form. This means that 8 over 27 is going to be 3 over 2 to power what? To power m. And now this, you can write it as what? 2 over 3 all to power 3, right? Equals to this now, this side now, you can interchange it to become 2 over what? 3, but now it will be minus m. Yeah. So it simply means that minus m is equals to 3. So m is equals to what? Minus 3. All right. So now that you have two sides, you can just add them. So it means your final answer will actually be 1 over 3 plus what? Minus 3. And this is 1 over 3 minus 9 over 3, right? Which is minus 8 over 3. So the next question, it's if the function, the x-intercept and the y-intercept. So you just need to find the x-intercept. So what is the x-intercept? X-intercept means you put y is equals to what? 0. So you have 0 is equals to log 927 minus x. And this means 9 to power 0 is just going to be 27 minus x. So 1 is equals to 27 minus x. So this will give us x is what? 26. So it means x-intercepts is nothing but 26 and what? 0. So we can pick it from here that a is equals to 26. And for the y-intercept, we're going to take x to be what? 0. So which is going to be f of 0. And that simply means log of what? 927 minus 0, which is just log 9 of 27, right? This is log 9 of 27. So what is log 9 of 27? We can write this as what? You can just say it's equals to what? It's equals to x. If you can find it that way, it's fine. But if you cannot find it that way, then you have to set it, or you try to rewrite this one in a form you can deal with. If you look at this, please look here. This I can write as log to what? To base 3 to power what? 2. And this one I can write it as what? 3 to power what? 3 to power 3. And one of the laws that we had is that what? If you, since this is power here, this one can go here to become half, right? So you have log of 3, but you still have 3 to power 3, right? See? So I'm using this law here. If you have log to base ak of x is what? 1 over k log of a of x. So this 9, I wrote it as 3 squared. So this is my k. K is 2. So k is 2, then it can go down as half. But here, this 27 is still here as 3 to power 3. All right, so take note. Now I can bring this 3 down. So you have half. The 3 comes down here, becomes 3 over 2. Then you have log what? 3 of 3. But we know that log 3 of 3 is 1. So this is 3 over 2 times 1, which is just 3 over 2. Okay? So it means that the y-intercepts, when x is 0, y is what? 3 over 2. So the b is actually 3 over 2. And then to finish, so we have that a plus 2b A is given to be 26 plus 2 times B, which is 3 over 2. So you'll have 26 plus 3, and this is 29. So the answer is A as well. So this also, the answer is A. Okay. So for number 8, what do we do here? It's still similar. We just have to, we have this one. This is log to base 3 of x plus 1 is equals to half. And we want to find this one. So the bases are the same, so there's no problem. But if you look at this, we can rewrite these as what? I can write this as log to base 3 of here. We can factor out 3. So you have 3, and then you will have x squared plus what's x squared plus 2x, then plus 1. So we just factor 3. Now, what is the goal? Because I have this one, so I want to see where I can use this guy here. But since they are the same base, it's all right. Now this we can write as log to base 3 of, again, this is 3. If you look at this one, this can be written as what? X plus 1 all squared. Then now we can change multiplication to addition. So this is log 3 of 3 plus log 3 of what? X plus 1 all square. And what is log 3 of 3 is 1 plus. Now, what is this one? This one, the 2 can come down. So you have 2 log to base 3 of x plus 1. And now we can use what we have. This is 1 plus 2 times what? What is log to base 3 of x plus 1? Is given to be half. So you just multiply by half. So it means that 1 is equals to, sorry, our final answer here is 1 plus what? Plus 1, which is just 2. So this is also A. Now, number 9 is similar to what we've done. So here you can see this 3 does not play any role. It's just a vertical translation. So it will not affect the value of x. It only affects the value of y, right? So it will only affect the range. So the domain will still be the same way. So the domain, we still need what? This to be greater than what? Than 0. And this we can achieve from where? We can achieve from our line tests. We can achieve from the line test. What will be the line test? The smallest 0 is coming from where? Because from here you will have what? You'll have 2, right? Yes. So the smallest is still going to be 1. And here we're going to have what? 2. All of them have to be open. So here we have to put, this is 4 minus 2, x coming from here. This is x minus 1. If you take any number between minus infinity and 1, for example, you take 0, this will turn out to be positive. This will turn out to be minus. So eventually it's going to be a minus. Between 1 and 2, you can take 1.5. Let's say 3 over 2, right? If you take 3 over 2, this will still be positive. And this is going to be positive. So this is positive. Between 2 to infinity, you can take 3. If you take 3, this will turn out to be negative. And this is going to be positive. So here it's just negative. So the only place where we have greater than 0 is between 1 and 2. So the domain is just 1, 2. So this is also A. All right, so here is also the same story. You just need to find 3, 4 minus x squared to be greater than 0. And here, if you look at this, you can write this as what? This is the same thing as 2 minus x, difference of 2 squares, 2 plus x, right? Yeah, because we have, in the denominator, we have this one, which you can write as 2 squared minus x squared, which will become 2 minus x and 2 plus x. So this also, we have our zeros here. There is no 0 coming from the numerator, so all the zeros are coming from the denominator, which are minus 2 and 2, right? And let's put our factors. This is just 3. Then this one, we can use this directly, or we can just use all the factors. 2 minus x, 2 plus x. This one is 3 is always positive, so it won't have any effect. If you take a number between minus infinity and minus 2, let's say you take let's take minus 3. This will be positive, right? But this will be negative. So eventually we will have negative. Between minus 2 and 2, we can take 0. This will remain positive, and this will be positive. So we'll have positive. Between 2 and infinity, you can take 3. You take 3, this will become negative. And here we have 2 plus x. This will become positive. So we will have negative. So you can see the only positive interval is from minus 2 to 2. All right, so the answer also it's A. And I think this is the end of this video. So thank you for watching. If you haven't subscribed yet, kindly do that and share this video as well.